So now, let's discuss the issue of limiting reactants or limiting reagents. So, here is the above reaction given above. Then they are saying if 124 grams of aluminium are reacted with 601 grams of that substance, calculate the mass of aluminium oxide formed. Then B, the excess reactant at the end of the reaction. So let's start. So when you're given a question like this, how do we proceed? So bear in mind, you are given the mass of all the reacting substances. When you are given the mass of all the reacting substance, it must click in your mind that they are looking for the limiting reactant or limiting reagents. So what is the first thing first? So we proceed. I'm going to calculate aluminium and for iron oxide. So for aluminium, we know the mass for the formula for the numbers of moles. It is mass over relative molecular mass. So the mass that was given for aluminium is 124. The relative molecular mass is 27. So these are the numbers of moles of what? Aluminium. I come for iron 2 oxide. Oh, iron oxide. So the mass over relative molecular mass. So the mass of iron that was given, iron oxide, was 601. Divided by the relative molecular mass, it was giving me this. Now, how do I find the limiting reactant? So I go back. I look at the two reactants. The ratio is 2 aluminium to 1 iron oxide. So I write 2 to 1. But bear in mind, this is for aluminium, this is for oxide, for iron oxide. So I first take the numbers of moles of iron oxide, which I place it here. Then I find the numbers of what? Aluminium, which was giving me 7.512 moles. So it means for 3.75 moles of iron oxide, 7.512 moles of what? Aluminium are needed. Then I go back. I come 2 to 1. Then I take the moles of what? Aluminium. I find the moles of what? Now iron oxide. When I calculated the moles of iron oxide, it was giving me 2.29629 moles. So these are the numbers of moles of iron oxide that are needed to react with 4.5925 moles of aluminium. So if you compare now these numbers, haven't you seen that for this amount of aluminium, 2.29 moles of iron oxide are needed. So it means this will be in excess for what we have. And this will be concluded to be a limiting reagent. Why? Because from the numbers of moles available here, it only needs 2.29, which means there will be excess of what? Of these numbers of moles. So therefore we conclude that aluminium is a limiting reactant because to react completely, it needs 2.296 moles of iron oxide, leaving 1.45995 moles of iron oxide in excess. So this is the question B that we have answered. Now they want us to calculate the mass of aluminium oxide. How do I proceed? So to calculate the mass of the aluminium oxide, now I use the limiting reagent moles, which means I'm going to use the moles of aluminium oxide. I cannot use the moles of a reactant which remained in excess, which means it was not completely consumed up. So I come here, which means it will be 2 to 1. Because if I look at the compound they want aluminium and aluminium oxide, which is in the reacting ratio 2 to 1. So which I'll put here. Then the numbers of moles of aluminium, it is this. Then I find the numbers of moles of what? Aluminium oxide, which was giving me this value. Then this value is the numbers of moles of aluminium oxide. Multiplying this value by the relative molecular mass of aluminium oxide, I have now the what? The mass of aluminium oxide, which was this. Thank you.